Hello and welcome to another deep dive. So this time around, we're going to be taking a deeper look at post-processing. So we've previously had a bit of a look at how we can set up post-processing effects in the different pipelines, like of that. And we've seen how we can blend between post-processing effects and doing that via things like of timeline, doing that where we are adjusting the weight between different volumes. So this time around, what we actually want to take a look at is rather than using the existing post-processing effects, I want to look at how we can set up our own post-processing effect. And I also want to show you how, if you need to change individual parameters for a post-processing effect, that we can do that in code. Because the weighted approach is really good in a lot of cases when we're doing sort of clean blends between different sets of effects, that can work really well. But if we need to potentially change one aspect of an effect, then that weighted approach may not always do everything we need. So it can be useful to be able to modify things in code. So let's dive on in and we're going to take a look. So starting point is we've got a fairly basic scene intentionally here. And I'm going to relocate our sphere back into the center. So we've got a really simple scene. We'll set it up so we've got a couple of different colors in that happening with things, just so we can get a bit of a sense of how things are being affected. And then we'll be able to see how we can actually customize this stuff. So we'll just get our ground as sort of a darkish green color. We'll leave the sphere there like that, and we might then also chuck in a capsule. And that capsule, I'm just going to bring it here, and we might make that a different color again, just so we have a few different ones that we can be seeing here. So the first thing we'll take a look at is how we can work with some post-processing settings, how we can change them in code. So first thing I'm going to do is I'm going to set up just a very basic post-processing setting. And in this case, I'm going to enable bloom. And what we'll also do with that, we can see it's having a bit of an effect there. Change the color as well, because that will allow us to sort of get a stronger sense of the effect there. So that looks pretty good. I can ramp that up a little bit. There we go. So we're seeing it really quite intensely there now, which is what we're after, which is great. All right, so let's set this up so we can modify that bloom intensity in code. So I'm going to call this post-processing modifier. And I'm just going to attach this onto, could go onto any object in this case, because I want to make sure I've got some extra sort of links happening there. I'm going to set this up just on its own standalone object. All right, so let's take a look at the code for this. So the way we go about modifying this is we need to retrieve the volume. So we do make any changes by talking to a particular volume. So the first thing we're going to need access to here is that post-processing volume. But in order to do that, we actually want to, because the settings are going to be changing, we need to bring in another using here. The one I want is Unity Engine rendering post-processing. So with the post-processing brought in, that's going to give us access to some of the key things we need to be able to directly access the post-processing settings. Now, what we're actually accessing will change a little bit depending upon the pipeline that we're working in. So whether we're working in built-in or whether we're working in the high-def or the universal pipeline, it does change a little bit. And the key thing that generally changes is the names of things, which we can always inspect the classes to identify what those names need to be. So in the built-in pipeline, we're dealing with a post-processor volume, whereas in the high-def pipeline, the the lightweight pipeline, the universal pipeline there, we're dealing with a volume, which that's the key sort of thing that will actually change there. So this would set up, so we have serialize field, post-process volume, linked volume, so we'll be able to access that. So now we want to then be able to, what I want to set up is I'm going to have a float here, bloom intensity, but I'm going to set to 1. And what I'm going to do is I'm going to set it up so that this bloom intensity is controlling the bloom intensity for the actual effect. So how I can go about this, so I can go linked volume, and then if we take a look at the things that we have access to, so we obviously have access to the weighting, but the key thing that we're after here is actually our profile. Now we've got 2 different profiles here that we can access, and it doesn't actually tell us which one is doing what particular things. So conveniently, this is where we can check the description. So this is where inspecting the code that you're actually accessing can be really helpful, because we can see here it is not recommended to modify the profiles returned by that. You recommended to use the actual profile setting, because this is going to go and refer to the particular one. So this automatically instantiates it. So this one is safe to be working with. So our profile. Now the way that we access the settings for things like Bloom and that is quite different to things you may have seen previously. So the way we access stuff is very different to what you might have seen previously. So we actually do this by doing a try get settings, and then we put the particular settings in here. So Bloom is what we would put in. And so that means we actually need this to be able to be stored here. So we would have Bloom settings. So then we usually would say, well, F, we try to get the settings. So it's an out parameter. So out Bloom settings. So F had successfully retrieved it. Now, if we take a look at those Bloom settings, then we can actually now access all of our particular ones. So we have stuff like intensity. But one of the things you'll notice is these are not just a float like we would expect. These are typically going to be things like a float parameter or a Boolean parameter. They're going to be different to what you might necessarily expect. That's because there's a bit of extra stuff going on behind the scenes with them. So intensity, if we take a look, I can then access the intensity's value, which I can set that to my Bloom intensity. So let's test this out. I need to link it up to the correct setting, but what I should find is that with it linked up, I can then just modify the intensity here. So let's test this out. So it's definitely updated it. We can see that its intensity is returned to 1. And as I increase this, you can see the intensity of the Bloom effect is ramping up. So that's good. So that looks pretty good. Now, in this case, I'm doing the get settings every time. But again, this is something where useful to check and see, okay, well, it's not telling us anything sort of specific there in terms of whether this is an ideal thing to do or not. We could check and see if we want to cache this, so we could check and see if that causes any issues. So it would be something where we would have our Bloom settings here, and then we would run this code. Now we still need to be checking that our Bloom settings is valid. So this is not equal to null. So let's check and see if this works okay. The key thing here is whether or not with that link is a persistent one. Likely it should be, but this will just allow us to confirm. And looks like it is. So we can adjust it. As soon as we stop it, we can check and see the intensity settings there are getting reset back. And then when we're running, you can see that that's changed, which is good. And if we tried to change this here, it's obviously not going to because it gets overridden. So that's good. So we can cache that it successfully got those settings. Well, what if we remove a setting, or what if we try and access something that isn't valid? So let's test that out. Because vignette, we haven't added a vignette. So vignette settings. So let's try and get those settings. So linked volume, profile, try get settings, vignette, out vignette settings. So that looks good. And then we'll try and do a similar thing here where we have vignette settings not equal to null, vignette settings, intensity, value, vignette intensity. So we'll set that up. Because this, what we're after is confirming that if that setting is not there, that this is set to null. That's something that we're wanting to confirm because that's a really important thing for how we're using it later on, because we are making an assumption that if it's not there, that it's null, which that looks to be a valid assumption. So that's good. So, okay, we can add the settings, things like of that. Can we add an effect? Well, let's take a look. Linked volume, profile. We have add. So we could do add settings. So this is something where with the vignette, what we could do is if it fails to retrieve it, then we say linked volume, profile, add settings, vignette, and then we say vignette settings is equal to that. So this would allow us to add an effect, we'd be able to remove ones, things like of that, so we can control a lot more of it in code in that case. So let's test. What I'm expecting is initially nothing looks any different, but if this is actually working, then that should have raised that up. And we can see that it hasn't, so we want to check with the post-processing volume. So the intensity has been changed, which is good. So this is one where we could check and see, have we missed something with the vignette? So intensity, as soon as I ramp that up, that is working. So let's remove that again and let's test and see. We want to look and have a look at what the behavior is here. So we can see intensity is at 0. Turn intensity on. And then if I try and modify this, then it changes. So this is something where we're trying to change a setting, but we haven't actually let it be able to access that. So we can take a look, vignette settings, and we can see, well, vignette enabled is likely going to already be true. We can check intensity, and intensity, we haven't said that we're going to override it. So we could check and see, okay, well, let's say that we're overriding that and we're just going to set a particular value. Does that change it so that now we're able to control that vignette intensity? Because we notice if we're paying attention that checkbox next to it was not ticked. And now we can see that it's working. Because if we take a look at the post-process volume, the intensity checkbox is now ticked, which it wasn't before. The reason it was fine for Bloom was because we'd already ticked that box and enabled it. So key things when we're working with post-processing settings from code, we go via the volume. And this is the case whether we are working with the high-def pipeline, the universal pipeline, or the built-in pipeline. The main thing that changes is the class here that we're accessing. It's post-process volume and built-in, and everything else, it's volume. Through that volume, we can access the profile. We can retrieve the settings, and then from those settings, we can change values. Now, if it is a value that we have not already said in the inspector that we're overriding, we need to tell it that we're wanting to override it to enable that override. Otherwise, any changes we make just get ignored. So we have to tell it that we're overriding it. And then afterwards, we can just change our settings. And whatever values we set things to, those are the ones that are going to be applied. Because we're going through the profile, it's not going to make changes to the original asset. So it allows us to make just temporary changes there, which is great. So that's gotten us to the point where we've got a modification of existing post-processing effects. What if we want to make our own? To make our own post-processing effect. Now we'll keep it simple, but we'll set up a base that we could be using and extending further. So, first step for doing this is actually creating a script. So what we want to think about is what we want our effect to be named. Because if you notice when we're retrieving the settings for things, they're not called things like bloom settings or vignette settings. They are called the name of the effect. That's a convention with the post-processing effects that we need to follow. So if we're creating something that, for example, was causing a grayscale effect, we'd call it probably grayscale. Or desaturate, because we might have it be doing a range in that it's not fully desaturating, we can actually control it. So I'm going to call this desaturate. And then we're going to edit this. So first thing is, again, we want to make sure we've got our Unity engine rendering post-processing. We need to bring that in. Now, we have to actually set up a couple of classes here. And what we generally want to do, this is another good case of setting up namespaces. So I'm going to call this desaturate effect. And I will have my classes inside that. So, first class that we set up is our settings one. So this is public class desaturate. And this inherits from post-process effect settings. And all this stores is our data. So this is where we would have our intensity for this. So we want it to have a range, 0 to 1, and this is a public float parameter intensity. And this is a new float parameter. We can give that an initial value, which will start it at 0. So this gives us our parameter. But we need to tell Unity that this is a post-processing effect, that there's stuff actually further to do with this. So key thing first, we want to make sure we mark this as system.serializable. Settings are properly able to be saved. And then we say post-process. Now we will be providing a renderer, which we'll be creating in a moment. So we're going to say type of desaturate renderer. So the first thing is we provided that renderer. Then we have this post-process event. So this allows us to control where in the post-processing stack this effect actually applies. So we can either apply it before all of the other post-process effects or after all of the post-process effects. We also have before the transparent items as well. So initially, I'm going to set this to be after stack. We'll also see what it looks like when we do before stack as well, though. And then we give it its name, so desaturate, which is cool. And by default, it's permitted to be present in the scene view. So that's for our settings. Now we need to set up our renderer. So public. So this is not something that any other things need to access. So normal convention in a case like that is often marking this thing as sealed. So it's a sealed class, desaturate renderer, and this inherits from a post-process effect renderer, which we link this to the settings. So we say desaturate. So that looks good. Now there's a couple of functions we have to set up, and there's really actually one essential function that must be there. So this is our public override void render. Now this thing, one of the things we need to do is we need to retrieve a shader. So it has to use a particular shader, and that's something that we create. So what I'm going to do is, because this is something where we might want to display the name of that, we might want to easily change it, a constant is usually a good appropriate setup here for this. So const string and shader path. Now initially I'm just going to leave that as blank. We will come in and fill that in after we've created the shader. So first thing we want to do is we want to actually load that shader. So we want to go shader.find shader path. Now if that fails, we need to yell loudly. So if shader is equal to null, then the first thing we want to make sure we return. So we're attempting to retrieve the shader. And there's a couple of catches with these shaders because we're referring to them in code that we'll see that we need to factor in for working with builds. Because Unity won't know that we're using this shader because we're only accessing it via code. So we have to actually specifically tell it that we're accessing it so that it includes it. Because otherwise it figures, well, you're not using this, so I'm not going to include it. So we need to do a little bit of extra there. But we also need to say log, and this is definitely a log error, failed to find shader, and we just indicate the path. So we've tried to retrieve the shader. Once we've retrieved the shader, we also then need to apply the settings. So to do that, we retrieve what's called the shader's property sheet. So attempt to retrieve property sheet. So to do this, property sheet, we can go context property sheets get for our particular shader. So it's in the context of this renderer, and then again, f property sheet is equal to null. We want to yell loudly because something's gone very wrong in that case. Failed to retrieve property sheet for shader, and again, making sure we're logging out the shader path, and we again return. So this is sort of boilerplate stuff that we're always going to need to do. Now we can transfer the properties. So configure the shader. So we go via the property sheet, and we can go properties, set float. Now we're going to go with intensity, and we can set that to settings intensity. Settings is something that's just automatically available, and the reason it knows which one is because this is a generic. So it's created the settings type within that. So we've configured the shader, so any of that configuration we do here, and then we perform our render pass. So context.command. Now in this case it's a full screen thing. We give it our source. We give it the destination. We give it the property sheet. Given it the property sheet, and then typically we provide 0 for the pass in this case. So that looks good. And this is fairly generic for what we would use for any particular shader. There are additional things we could be doing there for more complex effects. For this, we're keeping the effects fairly simple. So with that in mind, now we need to create our shader. So when we go to create the shader, we've got a lot of different options here. We actually want to, for this, select image effect shader. So not our standard surface or unlit, we want the image effect shader. And this is going to be called desaturate. And that looks good. So now that we've got that, so this, I'm going to put this as hidden post-processing. So hidden just means it's not one that's going to be selectable in a material for the user, which is what we want. This means that we can come back to desaturate and put that path in here. Now, there's a bunch of things we can get rid of with this. So firstly, we're going to clear out the properties there because we're configuring stuff manually. We're also going to clear out a lot of the stuff here. And we'll be making a couple of other changes as well. And I'm specifically going to be removing that CG ink there. So we've split this down a fair bit. We also, with this, we don't have a sub shader, but we will get to, well, we do have a sub shader, but we'll get to a couple of bits first. So first thing we want to do is a lot of the stuff we've seen is CG programs. So we want to use instead, rather than CG, HLSL, High Level Shader Language. Unity specifically recommends this in order to have your, and specifically recommends it in the context of post-processing effects in particular, in terms of having things work better with the different render pipelines. So we're going to stick with that. So that means we have HLSL include. And I'm also here going to, there's a standard library for high-level shader language, ones that has a lot of helper functions in it, similar to that unity.cg Inc. Provides us a bunch of helper functions. So I'm just going to retrieve, put that in. So with that, I can then set up my property, which will be float intensity. So that looks good so far. And then what we want to do is we then have here an end HLSL. So this is our first block. Then under the sub shader here, we have HLSL program and end HLSL. Now this shader library actually provides default versions of the vertex and fragment program. For the vertex one, that is called vert default. And we do just want to use the default vertex one in this case, but we are going to substitute in our own fragment shader. So we're going to set up a fragment one that we're going to be called desaturate frag. So this is going to look similar to fragment programs you may have written previously with a couple of key differences. So it's going to return a float 4. The input is this structure varying's default. And then inside that, all we're going to do initially is just return float 4. Well, we need to get our texture. We need to get our actual image that's being drawn. So to do that, there's a couple of texture samplers that we can set up. And I'm going to create a few different ones. I'm going to start off with just one, but we'll have a look at a couple of other things that we can do. So this is something, again, it's built into the high-level shader language one. This lets us easily define for our textures. So this main text will automatically get populated for us, and it will get populated with the current contents of the screen. So we can then sample that. So sampling that works very similar to how we normally would sample a texture. So float 3, pixel color, and we can go sample texture 2D. We give it that main texture. Now we need to give it UV coordinates and our sampler. So we have sampler main text, and then i.text coord. And then this will give us our sampling of the pixel color. And so we can then put pixel color and 1. So we just want to grab the red, green, blue from this. We don't want to grab any other aspects from it. So we're just grabbing the screen color and passing that through. So we're not making any other changes yet. We're not actually applying the grayscale effect. What we want to just confirm is that this actually, at the moment, should do nothing. is what we're after. At the moment, this should do absolutely nothing. So we'll go to our post-process volume. We will add in our desaturate effect, which you can see it's linked up. That effect would be running at the moment. And what we're expecting to see is, quite literally, nothing is impacted. That's how exactly it should be at the moment. Nothing's changing, which is good. So what I'm going to do is firstly just make that bloom intensity up to 8, just so we can easily be seeing that it's having an effect. And now we want to actually have our grayscale effect happening. So if we wanted to do the grayscale effect happening, or the desaturation, what we could be doing is our pixel color here, we could be lerping it with our intensity. Is the thing that we can be doing. So let's get this set up so we can be doing that. Particular grayscale value. Now there are other ways of doing this. This is just a very simple way to illustrate the effect happening. So we can do a dot product with that. Now this gives us our desaturated version. So that gives us that desaturated version. What we then can do is we can change that, and we do a lerp based upon the intensity. So we can do a lerp from pixel color to this new value based upon intensity. So we would be able to then go pixel color equal to that. Should give us something that as we then change that intensity, it actually changes the effect. Now, we do want to make sure that we've provided the right number of arguments. We have done our dot here. So we've done our dot and then lerp as that. So we've got the particular ones right. That looks good. So it's for the numeric type construct. So that's for this. We missed having the 3 in there. Very easy to miss. So if we select our volume, we want to overwrite the intensity and ramp up the effect. We can see it's applying it as making it more grayscale. Now, I was saying that we can have with our post-processing effects here this before or after stack. So that was after stack. So with after stack at full intensity, the screen is entirely grayscale. Now let's go for changing that to before stack. So this will run it before all of the other post-processing effects. And what we'll see, we ramp this up, and because it's running before all of the other things, the scene, most of it, is going to be made grayscale, but the effects that come along afterwards can introduce color. So this is something that you could use for some quite interesting effects there, potentially. So whether something is before or after in the stack does make a big difference. So in this case, I'm going to switch that back to being after stack. So that gives us a couple of ways where we can do some interesting things there. I do want to change my project so that we have the shader actually being reliably included, the easiest way to find where we need to put those settings is if we do a search for shader, then under graphics, always included shaders. Going to increase that to 7, and then we are going to select our desaturate one. This just guarantees that it's there in the build so that we don't have any issues where that effect does nothing, because that's very much a possibility of what could happen. Now we have access to other bits of information at this point, and there's a couple of other things that we do have access to. We have access to depth information from the camera, and we also have access to normal information, so normal map data. And we can use those for doing other effects. So I'm going to, if I want to access the depth texture, how I do that is I have another sampler. So texture 2D. So texture 2D, sampler 2D. And in this case, the name for this one, and these names matter. You have to make sure the name matches, otherwise it's not going to find it. So camera depth texture, sampler, camera depth texture. So that's good. So what I'm going to do is, so this is the desaturation frag. I'm going to set up one that I'm just going to call depth frag. Varyings I. This just makes it easy for me to chuck in other ones, because I'm going to switch this then to the depth frag. And what we'll do is we're going to sample our depth texture. So we actually have some helpers for this. So float depth, sample depth texture. We provide the name for it, camera depth texture. And as with the other ones, we need to provide the sampler. We provide our sampler in there as well. And same with the other ones, we need to supply our texture coordinates. And that will give us back our depth. So I'm going to just draw float for, or I use depth for each of the parameters, apart from the transparency. Because what this will do is this will allow us to draw what that depth information looks like. And we can see now closer towards the screen is going to be brighter, farther away is going to be darker. And if I move something, now that's moving around. You can see as it gets closer, it gets much, much brighter. So we can access depth information, which can be really useful for some effects. We also can access normal data. Now, normal data is a little bit trickier for accessing, and how we go about accessing it can vary a little bit depending upon the pipeline settings you're using. And it also is stuff that can vary a bit in terms of whether we're using forwards or deferred pipeline there for rendering. So if we're using deferred, it's much easier. We have information always available to us. If we're using forward, we don't necessarily have that. So what I'm going to do is we have a couple of ways of sampling that texture. So firstly, I'm going to set up a version that will work with forward or will work with deferred, but we typically won't see it in the inspector. We need to actually be running to see the effect. So sampler 2D. So this time it's called a camera depth normals texture. Sampler. And this is a camera depth normals texture. So I'm also going to then set up a separate one here that I'm going to call normal frag. Just so we're keeping this stuff nicely separated. It makes it really easy then to be reusing bits and pieces. So I'm going to switch this over to using normal frag. So how we actually retrieve the data from this. So when we sample that texture, what we get back is actually something that's an encoded normal. So we get back our encoded normal by doing a sample texture 2D. And like with all of the other ones, we provide our setups. And we need to provide, again, our texture coordinates. So as per usual, texture coordinates need to be provided. So I text coord, and your autocomplete may not always play nicely. So we've got texture coordinate. Now we need to decode that. So float for decoded normal. So for decoding this, and this will actually give us a float 3, sorry. So it's a float 3. So to decode this, we have a function decode view normal stereo. And we give that our encoded normal, and then you multiply 1, 1, minus 1 to flip things around. And now we can return a float 4, decoded normal, and 1. So it's a little bit of an extra few steps there to do this, unfortunately, but that will give us the data. So it should be showing the normals. And then it's finding a float that it's not happy with, and that's because I missed a semicolon. Always the way. So immediately, it's not showing anything. Try running it, still not showing anything. If I change the rendering path to deferred, no, still nothing. And I could force that to deferred from the start and run it. No, still nothing. And that's because in our setup, it won't actually generate that depth normals texture by default. We have to tell it to. So we have to actually add a script onto our camera that will turn that depth normals texture on. So force depth normals. So this is going to sit on our camera in this case. So require component type of camera, just so we can easily retrieve it. And then camera get component. Then what we do, we go camera depth texture mode is equal to the current one, plus we add in by ORing depth texture mode, depth normals. That would force on that generation of the depth normals that we otherwise wouldn't have. So we can attach that onto our camera, and that will just mean that will force that on. So if we run this, we've got our normals showing. So we, by default, will be in forward rendering. We can check and see, okay, does that work in deferred? And in deferred, it works as well. So it will work in both. It's just not going to be visible there in the scene view generally. What we can also do is there is an additional way of accessing this using something called the gbuffer, which is available in the deferred by default. So this extra one, we don't actually need to if we're using deferred rendering generator. What we can do is texture 2D, sampler 2D, and then we have, so there's a bunch of predefined ones, but in this case we're accessing gbuffer texture 2. So you realize it's a really obscure name to track down. There's a bunch of gbuffer ones. 2 is the one that is going to hold the normals information for that depth buffer. So this has sampler, camera, gbuffer, texture 2. Now, the way we sample this is actually different. So I'm going to set up a helper function here for retrieving the depth normal. So sample depth normal. And I'm going to make it that what it will do is you give it the UV coordinates, float to of UV. So that'll mean that I can bring this up into here and be able to then say, well, actually, I can just directly plug that function in here and go I text coord XY. So it means this changes to UV. That's just working exactly as it was before, but this is not using the gbuffer. Then for the gbuffer version of this, I'll show you what that looks like. What I'll do initially is I will just comment these lines out. So we'll end up with 2 different versions. So that's the non-gbuffer version. The gbuffer version looks a little bit different. So, float 3, normal. So we retrieve this, similar approach to before. We do our sample texture 2D. We again provide same set of ones as before. And again, our UV coordinates. So up to there, nothing different really, apart from we're referring to a different texture. Now the way we translate this is different. So this becomes a return. We do a multiply. We're multiplying. So we get our unity world per camera. Camera. We have to actually transform that normal into the camera space. So we get our matrix for that, and then we give it our normal. We can just return that. Now this approach, we go back to here and we test it. Well, we see nothing. And even if we go and run, we'll still see nothing. But if I switch to deferred, it works. So this approach will work in deferred without us having to do anything extra to the camera. It just is there and is working. If we were doing this in forward, we won't have access, even with that extra script, we don't get access to that particular setting. So it's not uncommon we can wrap this in a couple of checks. So F, things are coming from the G buffer. And we use that. Otherwise, we use this other approach. This just gives us something where we can define that so that we know, okay, yep, here's the version to use. Just makes it a little bit easier, and we would also do a similar thing here for grouping this. So that just gives us something that if we need to, we can turn this off and on. G buffer and F. And so that will go back to using this one, which is good, which will be back to working forward and deferred exactly the same, just with the proviso that we have that extra script there forcing the camera's mode. And so I'm just going to switch this then back to the desaturate one because we've got it up and running. So key stuff when we're setting up our custom post-processing effects. There's a couple of things we need to create. So one of the things is we need to create the class to hold our settings. That allows us to control where our effect runs. Does it run before or after the existing post-processing effects? We set up our renderer, where we can link to the particular shader. We want to make sure we're doing some error checking, that we've been able to find the shader, that we've been able to find its properties. We transfer those properties over, and then we perform our full screen blip that will run our process there with our shader. In terms of our shader then, we generally start out with an image effect one, and we switch stuff over to be HLSL rather than CG. We could do this using CG, but again, that's not recommended from a point of view of longevity. So we generally want to go for having it be the HLSL ones rather than CG. And we saw we were able to access different things, how we could sample our screen, how we could sample depth information, how we could get normal information, and how there's a couple of catches with normals, where if we're in forward rendering or deferred, if we're using this camera depth normals texture, we need to specifically tell the camera to generate it. We had to do a little bit of extra work there to make sure that's enabled. Whereas if we were just in deferred, so if our shader, if we knew we were only working deferred, we could just use this G buffer because that will always be there in a deferred render. So it gives us a way of being able to work with that. So that's the key stuff for being able to set up our effects there. And obviously also remembering any of our custom shaders we add in, make sure we put them in the always included shaders so they end up in our build. Otherwise, we can't guarantee that they will end up in a build, which can mean that our shaders end up missing and are not actually working and available there, which is less than ideal because we want our cool shader effects to be visible. Hope you found the video helpful, folks. As always, the full code for this project is up on GitHub, and the link to that is in the description below. You're freely available to use this code for any of your own projects, whether those are commercial or non-commercial ones, with no restrictions or requirements there. So dive in, use the code, experiment with it, see the kinds of cool things you can create. If you got any questions, chuck in a comment below. If you've used the stuff in any projects, I'd love to hear about projects you've used it in. Always cool to hear. If you have found the videos helpful, also is a big help for liking and subscribing. And if you're looking for other ways to support the channel, I do have a Patreon set up, and the link to that is in the description below. Bye.